It's Friday, May 15th, and today on the live stream, I'll be trying to use the Kubeflow Pipelines SDK to deploy a pipeline to AI platform. Here we go. Hello and welcome to the live stream on Adventures in the Cloud, where we explore new and interesting concepts, tools, and ideas live in the cloud. My name is Yufeng Guo, and today I am delighted to be joined by Brian Kang. He's a machine learning specialist at Google Cloud, and he loves pipelines. How are you doing today, Brian?
I'm doing great. Thanks for having me, and I'm really excited to talk to all of you. So thanks for having me.
Awesome. And I guess, yeah, we kind of went over the beginning already. Kind of we're going to be doing pipelines, and on, what was it now? Monday this week, I got a chance to explore setting up a AI pipelines environment. And so now we get to push some real stuff to it and kind of dig into the SDK code. And I looked at how there were two choices, right? You could do it with TFX SDK or the Kubeflow Pipelines SDK. And so it'll be interesting kind of to try both and then compare each one. So today we're going to focus on Kubeflow Pipelines, and really appreciate having you on, Brian. You know, your kind of knowledge around pipelines and your prior experience in it really is going to be super handy. So our viewers
Awesome.
oftentimes want to know what we're going to be kind of working off of. And so today we're going to be using kind of a existing kind of set of workshops, mini workshops, labs. I'm not sure what state they're in. Like, are they finalized? Do you know, Brian?
Yeah, I'm pretty sure. I mean, the third one looked like it was still in draft form,
Okay.
but the first two labs are good.
Awesome. And so I'll paste that link into the live chat for folks who want to follow along. We've done a few setup steps already. At the beginning of the repo talks a little bit about kind of what you need to do to create an environment. It's nothing we haven't seen before on this live stream. It's really just make a notebook, make a BigQuery table, set up a few environment variables. But we can like point that out as we go through. So I'm going to move over to the pair coding view, and I've got the repo up. So this is the link that I just pasted into the live chat. And as we can see, there's kind of 3 labs, and today we're going to start with the second lab because that's what focuses on kind of the core pipeline pieces of things. Brian, do you want to talk a little bit about what the first lab was, just so people have a little context?
Yeah, absolutely. I think it's I like the way they ordered these labs. So each of the labs gives you a little bit of context about the steps to take for this process. And lab 1 is just primarily a lab around just doing a training of a standard scikit-learn model, and then training that and using predictions on AI platform training and predictions. And so it kind of gives you the foundation for what you need to understand about the model before you get into the pipelines. And then when you get into the pipelines, which we'll do on this live stream, you'll kind of be able to compare how different it is and where the things are slightly different, which is kind of cool.
Yeah, definitely. So I guess part of the reason we're skipping over this for now, at least, is today we want to be like sensitive to the time and stuff. So we'll go straight into lab number 2, which, as I understand it, is all about the pipelines piece of it. And so I guess, let's see, we should talk a little bit about what I've already set up. So in the GitHub repo, there's a top level README. Well, no, sorry, in that folder we were in here, the original link, there's a top level README which goes through preparing the environment. And it essentially helps us set up a deep learning VM, which we've done a number of times, but this time it's with a custom image. And the custom image is defined by this Docker file here. When it uses the base CPU image and installs, I mean, it really only just installs kubectl. But it does that, and it installs a couple of Python packages. One is Kubeflow Pipelines, of course, and then there's this Fire package, which I had to go look up to figure out what it did. I hadn't seen that before.
Yeah.
And then Google Cloud Storage File System. I think that's what this stands for.
Yeah, and I'll just add, this is something that a lot of enterprises and organizations do. Mm-hmm. So it's pretty common for them to start with an image that already exists out there, add their flavor, and then package it into a Docker container so they can use it for, their own purposes.
Right.
So, yeah.
Yeah, no, definitely. And like this workflow can kind of be easily adapted to kind of serve that purpose. At the end here, it talks about finally creating that notebook instance and gives the command line kind of method of doing that, which again is really useful for automating this entire process. I personally did this
Absolutely.
on the UI, but
yeah, you could do it either way. And I also add just around the container part. The nice thing is, if you wanted to use the deep learning container as the master golden image as your starting point, and then let's say the image gets updated by Google, then you can just recreate your custom container by starting from the updated image and then adding your 3 libraries, like in this case. And then you're not having to maintain the whole container.
Right.
And having to update every single library, which is kind of nice.
Yeah, for sure. And I guess, do you want to also fill in viewers on what this Fire library does? Why we need it?
Yeah. I have no idea.
Oh, okay. Fair enough. I thought maybe you were aware. It apparently is.
It sounds awesome.
I know, right? It's Fire, Python Fire. It executes command line arguments for you. Basically, it looks like it's some library that fires off commands.
That's interesting.
Yeah. So
I mean, how do you usually do that, with importing OS or something?
Yeah, I think that's the hack, and using Fire I think was probably just a convenience method for them. So I guess with that out of the way, we should I want to point out that I already created a notebook, and at the beginning of this process, at the bottom of after you create the notebooks, it's easy to miss this final step because you've jumped into the Jupyter Lab environment, is you've got to also create a BigQuery table. I forgot to do this the first time. And what this does is it pulls in the data set that we'll be using. And in particular, it's this cover type data set, which I found a little more about. It's also in the top level of the repo. So if you go to here and click on data sets, we're doing the cover type data set, and talks a little bit about that and kind of what the columns are. So it looks like it's kind of talking about the cover of over the ground physical cover, and it's coming to us from that classical UCI machine learning data set as one of them. So there's just over 500,000 rows of data, and it there's a lot of stuff here about it. We won't go into it too deeply, but the idea is to predict the cover type of a farce cover given a bunch of kind of mapping and geographic related variables. Anywho, I guess we'll start from lab 2, and we can talk through kind of the code as we encounter it. Does that sound good?
Sounds good to me.
All right. So this notebook kind of is going to hold all the pieces that we need to run through and understand. So let me bring this window in a little bit more so that everyone can see all the parts, and I might actually just collapse this for now for spacing. It talks about kind of this cover type training pipeline, which will generate below. And I guess this is an interesting idea that is worth exploring a little bit more. This notion of using notebooks to generate Python files, as opposed to converting a notebook into a script top to bottom. And this pipeline, right, already exists, it looks like, and
yeah, it's just part of the code that you downloaded into your Jupyter environment.
Oh, interesting.
Yeah,
okay,
it's right there.
So there's already some existing stuff.
Yeah, someone wrote this Python code,
okay.
But you actually don't need to have had this because the lab will actually create it for you in the next step, I think.
Yeah. Okay. So the pipelines, and we should talk a little bit about the idea of a domain-specific language, because DSL is going to come up a bunch as we work through this.
Yeah.
So let's see. We've got our pre-built components. It says this pipeline uses a bunch of pre-built components. So is this worth kind of exploring a little bit more about these pre-built components?
Yeah, we can explore it. And it's basically just like, libraries that are already, available for use versus others that you have to do a couple additional steps for.
Gotcha.
Yeah.
Okay.
That's how I understand it anyway.
So this first cell, it looks like it's just a replica of what that Python file was?
Yeah, but it will recreate that file.
Right.
So, yeah.
Okay. Should we walk through this code, or is there more interesting stuff after?
Actually, it's an interesting part to walk through. Great. Because this will help you understand kind of how the pipeline is set up. So if you scroll, like at the top here, there's a number of libraries you need, and then a lot of variables that you need to set. But if you go down a little bit further, the other way, thanks. Yeah, and then there's some hyperparameter settings that you'll want to have, of course. But I mean, that's more for the machine learning or data scientists. And then you scroll down.
We have a generate sampling query.
Yeah. Which is important. Yep. But I guess the main thing I wanted to add, but you can, if you want to talk about the component factories, that's fine. But as you can tell, there's some of the standard ones here, and then the custom ones they're using as well.
Right. So these are the standard ones?
The BigQuery, the ML engine, train and deploy, for example. Yeah.
And
then the interesting thing is, see where it says KFP DSL Pipeline? On the next line below.
Oh, yes. This decorator.
Yeah, so that basically is where you define the steps in your pipeline.
Okay.
Which is really nice. I mean, you basically define each step and then the relationships of those steps, and this is how you determine what the pipeline's how it's gonna get orchestrated.
So this is like the real core piece of it that we need to understand.
Exactly.
Great.
Yep. And when you're in Kubeflow, and I think you were showing it on your first one, and you're going to the graph.
Right.
This is how you build the graph.
Okay. There it is. So this is the guts.
It is.
Very quickly able to kind of get into it. It's nice.
One thing I wanted to mention is I don't believe chat's working because no one said anything.
Oh. So let's if you're on, feel free to say hi. Let us know where you're tuning in from, what you're kind of interested in hearing more about, questions you might have as we go.
There we go.
Everybody, thank you.
Test 1 2 3. Nice.
All right, so chat is working. People were just we're being a little bit shy. It's all good. So let's take a look at this this function and see how it pieces everything together, and how we can think about how we want to kind of structure the code to get the resultant pipeline we're looking for, if that makes sense.
Yeah.
So this says it creates the sampling split, sets a training file path, and then I guess this BigQuery op just like runs a query.
Yeah, so you'd have to go back to the query itself, but I think what it does is it just gets like 80% or so of the data as your training file based on the query and the logic in the query. And then same thing with the validation set. It gets a smaller percentage.
Gotcha. Oh, I see here. This is where BigQuery op was defined. I was trying to figure out where that function lives, but like you said, it's a pre-built one.
Yep.
And then we give it a query, which somewhere.
I mean,
here. Interesting. So there's a lot of kind of not meta programming, but just like things are definitely abstracted away from each other, so to speak. It's not directly kind of all the details in one place. This is kind of the high level architecturing of all the kind of steps. So then after we run the training split and then the validation split, and then the test split, gotta get them all. Testing file path. How is this separating all the different things? Oh, I see. This is where the query is defined. So each one is generating a different query with different lots, looks like.
I see. I guess this is a little different from the lab one.
Yeah.
So in lab one, they did it with the SQL,
Mm-hmm.
but here they're setting it a little bit differently.
Yeah. There's whatchamacallit, this function, right, which does run the SQL at the end of the day. So this is the generate sampling query, and then lots is like what is it?
Oh, you know what? No, this is the same query.
Okay.
Yeah, they're just using variables to replace the values,
Yeah.
which makes sense.
Cool.
Yeah. Yep.
So then, let's see, where were we? Hyperparameter args for the split? No, that's not right. What is this doing? Creating and that outputs. Because this was a function, wasn't it?
Yeah, so this is basically creating the file, I think. Let me just make sure I'm looking at this right. I think it's creating the training file and the validation file, unless I'm on the wrong line.
Okay.
I have to double check, but that's what I think it's doing.
Yeah, let me see if there's a show line numbers. Does anyone know if Jupyter? I feel like Jupyter should have line numbers toggle. Oh, here it is. Show line numbers. So now you can
I have it on mine.
more easily map your view with mine.
Mm-hmm.
But this is basically a Kubeflow pipeline component, I want to say. Is that what we would call it? Because like a random Python variable, you can't just like call .outputs on it.
So let me look. Create training split. That's an actual BigQuery op.
Yeah. So what are these ops, so to speak? That might be worth exploring.
So if you were like using Python straight, you would import the BigQuery library, and then you would use like the BigQuery functions, right?
Yeah.
But it looks like, and I haven't used this a ton, so I'm kind of like similar where you're at, but it looks like it kind of abstracts that, and you just like like if you go up, create training splits or split, you set up to use that op, and then you pass in a certain set of variables, and that allows you to basically I mean, I have to look at the documentation on this, but allows you to kind of like call functions or call procedures using that op,
right,
without having to write the Python or the straight up Python code again.
What's interesting here is, as you're talking about it, that I'm realizing is I don't think the BigQuery query is actually executing when this code runs, and specifically even when this is called and it creates this create training split variable, the query still hasn't run. Does that sound right to you?
Yes, because it's just creating the pipeline. It's not actually running the code.
Yeah, and so that's kind of an important detail that folks might want to keep in mind, is that when they're running all of this code, they might not see all the errors they might expect, right? You could like be pointing at a table that doesn't exist because you have a typo or something on the table name, and you wouldn't really know it until later.
Right.
Okay, that's good to know. Yeah, because I had been thinking that like this like was returning the table or returning the results or something, right? We're so used to working in a situation where we get the data back. When you query BigQuery, you get the data back, and then you can do stuff with it. But here we're like setting up a structure for it to execute later.
And I think I don't know if it's in this necessarily in this lab, but there are ways you can check to make sure the pipeline is like solid before you
Yeah, I think I've seen things around that, around just like executing individual components, basically a way to test your components as you go.
There's an actual, it's actually in the lab 2.
Oh
If you
yeah,
go down to if you go back to lab 2 and then
this is
go
lab 2, right?
to,
Yeah.
yeah, so use the CLI compiler to compile the pipelines. This is a step. And then it compiles it. So if it's not successful, you'll get
Nice.
you'll get some error
Yeah,
messages,
down
I'm
here.
sure.
So when it comes time to do that, we'll get that.
It would be curious to try like setting it to a
Something wrong on
data
purpose.
set or something.
Yeah, yeah.
Yeah.
Yeah, let's try that. Where's the query? Source table. Source name.
Is
Query equals template source table name. So generate sampling query needs to get the source table as a variable. So if we pass the wrong source table, it will make it not work.
we'll see.
Source table name. That's been called here. So this function is actually taking this as an argument. So we have to dig around to find out who is calling. Yeah, who's calling this function then? This entire cell. It's a component of the pipeline. So I think that's being passed in at the, in the data passing aspect of.
Yeah, I'm looking at it right now. It says cover type training pipeline.yaml. That's the result of it. Training pipeline.py. DSL compile. And then in the pipeline.
I guess the hope is that we'll encounter it at some point, right? So we can tweak it then. Cool. So let's continue on. It looks like this is setting up the ML engine train op, which for folks who aren't familiar, AI platform training used to be called machine learning engine or ML engine. And so whenever you see something that says ML engine, it's referring to the same thing as AI platform, either training or prediction. And so then we retrieve the best trial. So there's a retrieve best trial up. That's cool. Where did that come from? I'm trying to see if we did write that ourselves, it looks like. Is this just another way to, instead of using a decorator?
I'm not sure, but I know like from lab 1, for example, it basically got the best runs.
Yeah, it looks like it's getting it
those
from helper components. So there's a helper components library or folder here. That's this script. So retrieve best run is this, and it's just a plain old Python function. There's no decorator. And so I guess that's why they needed to wrap it in this func to container op instead of having a decorator on top of it like this.
Yeah, and you're just asking about what the built-in or the built-in components versus the custom ones are. This is a good example.
Yeah, because I saw that we were using this op later down here. That's where we were to retrieve the best trial. And I was like trying to figure out where did that get defined. It's one of my favorite things about Python is that for the most part, there's no kind of super magical variables and things you can like beyond the standard library. And so every variable has to be on the page somewhere. And so we can like trace things back, and it's super nice.
Yeah.
And so we've got our best trial, and then we have all these training arguments in a list, which we pass into the ML engine train op. Then we do basically the same thing for evaluate. And this is interesting. We've got a DSL condition, and it's a with clause. So this, does it cause a branch in the visualization then?
Let me look.
Right here.
I'm actually looking at the plot. So where is it at?
210.
Which step?
Yeah, I think you can see my screen, right? Yeah, so you can follow along that way as well.
So eval model, and then condition.
Yeah, with KFP.DSL.Condition. And it looks like it's comparing the output kind of values. If it's better than some threshold, then we'll replace it and deploy a new model.
Yeah, that's cool. Yeah, I didn't even notice that one. So basically, this is what, a lot of I mean, the team I'm on, this is what they're doing.
Yeah.
They're looking at a metric and determining whether they need to rebuild the model. But this is a very simplistic metric.
Of course,
obviously.
yeah.
You want it to be more rigorous than that, but this is kind of how you would do that.
Yeah.
This is cool. And then basically, if it doesn't meet that condition, it just doesn't deploy it.
Right.
Yeah.
And what's also funny here is that, like you said, this is a pretty lax condition in that it's a hard-coded metric threshold. So like say that threshold was like 0.8, and then if it exceeded it and got like 0.9, it would get deployed. And then if the next one came out and it was 0.85, which is worse than the old one, but still over the hard-coded threshold, it'll overwrite and become the new one.
Yeah, you want to look at a lot more, actual metrics than this one. Yeah.
And so that gets written out as one big Python script. Really handy tip for folks who are trying to do that. Just the fact that Jupyter has this magic of %% write file, and it just writes whatever is in that cell to a file. So it's really quite nice. And so then there's two Docker files that are in these two folders, one called base image, one called trainer image. And what we're doing here is it looks like we have our base image, and then we install. So even our base image has a few things to install. Fire, again, don't forget the fire. And scikit-learn, pandas, Kubeflow Pipelines. And then
I'm gonna use that library just to say I'm using Fire.
Exactly.
It's just an awesome library name.
Yeah, they claimed it, and now they own it, which is a strong move. Oh, look at this. Isn't this funny? The trainer image has a different version of scikit-learn than the... oh, no, I looked at the wrong thing. No, it's the same. I was going to say that'd be crazy.
Yeah.
So
yeah, that would be crazy.
The training step employs the AI platform training component to schedule a training job in a custom training container. And so that's this Docker file. It's defining the container for AI platform training to run, as opposed to this base image, which is what's going to execute our pipeline. Our custom components will execute in this image. And so that's why we need KFP here, but not in this one.
I think so. Yeah.
Cool.
I have to dig into it more, but yeah, looks like it. I think you're reading it right.
And then, this is worth pointing out. Where did these variables come from? Right. So they've set us up really nicely, but it's worth knowing what you should fill in if you're working along with us in these fields. So endpoint refers to where the pipeline is running. So on Monday, I was kind of in this view with all these different pipelines running. And when we're in AI platform, we can click on pipelines on the left here. And then when we click open pipelines dashboard, it takes us to this page. And that URL, just everything after the HTTPS up to the .com, that's the value that is reflected here. So, thanks to Brian for kind of pointing me in the right direction for getting that put together.
Yeah, absolutely. And the same thing with the artifact store URI. You're going to want to change that to the bucket that gets created for you when you set up this environment. And as Yufeng mentioned earlier, it's just right on the GitHub README for the MLOps, the lab. And if you go through those setup steps, these will be created, and then you'll be able to get the links.
Right. In this case, I think it's another kind of subtle step. Is it early on or later? Oh yeah, creating an instance of AI platform pipelines. It looks like it's a brief paragraph, but it's actually links out to a different guide. It's in fact the guide that we used on Monday, and the storage folder is an auto-generated one. And so you can see it will always start with hosted KFP-default. And so that's how I found my URL. I went to storage and I was like, all right, it starts with an H, hosted KFP, aha. And so I copied this, and because otherwise it's like, I can't find that. And then, pasted it in. And so then we were off to the races. And so now we got to build those images that we kind of outlined above. We had that base image, and then we had the image for AI platform training, which I have built in advance because it takes 8 to 10 minutes, and I'm not good enough at tap dancing to last that long, and additionally, we would run out of time. So it looks like this one.
You're being humble.
I think that one worked out, and so did the other one. So I ran the other one in the command line because.
Yeah, and I'll just add there that we did talk about maybe using larger machines, and basically like for this step, and then for the training step, which also takes about 8 to 10 minutes, specifying which machine type to use for AI platform training and prediction to basically maybe speed up the time.
Yeah.
But in a live stream, no need to just sit here and wait 8 to 10 minutes. You guys will do the same when you guys go through this step.
So this next cell, I think we're going to compile the pipeline, and this is kind of an important step to be aware of, I think, right? Of just like the workflow. When we think about pipelines at a top level of just like what are the steps needed to go from raw code to running pipeline. And this is an interesting string here, this fixed URL. There's a component URL search prefix. I'll be interested in seeing how they use that. And it says we can use the CLI compiler to compile the pipeline. So what exactly is happening when something is being compiled?
It's just checking to make sure it passes validation tests. It's almost like it's like when you compile any code, right? It's generating like either probably an executable of some sort. I don't know how it works behind the scenes, but it's compiling the pipeline for execution and probably checking to make sure everything's valid.
Whoa. Look at this.
Yeah.
So this is
it did mention that it's using Argo, just to kind of like if you look at the top, it says Argo project.io v1 alpha. So that's an interesting piece of info, although I don't know if you can actually see the visual representation like you can in Argo workflows. It's an open source orchestrator similar to Airflow or something like that.
I see. I just realized I was like trying to figure out where this YAML was defined, and then I realized that's what this DSL compile has done. It has created this file.
Yes, it's an output.
Okay.
Yep.
So when we talk about what's happening in this compile step, it's taking the Python code and turning it into a very messy YAML file. And it says it right here. Silly me. And so let's see. It does the head of that YAML file. Yeah. I mean, I don't think anyone's going to argue with the note that this is a messy YAML file.
But I mean, that's what you kind of get with the auto-generated code, right? And that's why a lot of developers hate the auto-generators, because it just writes really terrible code sometimes.
So now we've got to deploy the package. So is this going to push it into the server that we're using? It looks like there's a KFP command line tool.
Yep.
We point it at that endpoint, which is that URL that we're looking at up here.
Yep.
And then we've got our pipeline name, which I think is just some generic name for the pipeline, and then our YAML file, of course. So it says a bunch of stuff. Pipeline, blah, 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 has been submitted. ID, here's our name, cover type, continuous training, uploaded at, and then a bunch of variables that we don't have corresponding values for. So that's fun.
You'll want so going back up to the top of that, you'll want to make note of the ID.
Oh.
Because that's a piece that goes into one of the next steps.
Okay. So that's good to make note of. I'll drop that in this README that I've got going just as a paste bin. Cool. All right, so hypertune settings take up a lot of space. Okay, submitting pipeline runs. Before we do that, well, I can run this, but I want to go and go to the UI and see it, because this is as nice of a layout as this UI is. I think we can do a little bit better. I'm going to click this refresh button, and if everybody will cross their fingers with me, hopefully we'll have a fifth item there. There it is. And so there's our continuous training for our cover type data set. And there's our graph. We've got 2 BigQuery queries, and going into a submit job, submit a cloud ML training job as a pipeline step.
I love it.
And then retrieve the best run that we were looking at that. So this is
Yeah.
probably the hyperparameter tuning training, and then it gets the best run. And then we get to submitting a Cloud ML training job as a pipeline step 2. And then another query. I wasn't aware of that query to go into evaluation. Oh, probably to grab the evaluation data set, of course. So this is one is training, one is test, and it goes and then I'm gonna hide this so we can
and
see
then
the
it's in
rest.
and it's in that last step of checking to make sure that the model is better.
Evaluate model. Ooh,
Yeah.
a big thing.
Yeah. And then it will deploy it if it is.
Oh, and that's that condition.
Yeah.
Outstanding. And I see we have a little information here. There's versions uploaded, and we didn't give it a description because reasons. And it's interesting that this is yellow. Is it just because it's a condition, so it's like a different type, so to speak?
It could be. Yeah, it could be. I'm not sure, but it also the colors will change as it runs.
Oh, okay.
I
Well,
wonder
it
if
hasn't run
stays that way.
yet, so we'll see how it goes.
Yeah.
So let's submit that run. Oh, this is that pipeline ID you were talking about. So we're going to replace that with the value that we've got.
Yep.
And then, and would there be another way to access that ID if I like forgot or something? Like I forgot to save it or I lost it. Oh, it's down here.
Yeah, there it is.
Awesome. Okay, so that's good to know for folks' future reference. So we're going to set a few environment variables. Dataset ID, staging path. Ooh, fancy. Artifacts, store URI. Oh, that's that. Yeah, same place as before. And so I'm going to kick this off, and then we can talk a little bit about what all these command line flags are talking about, because that is a lot of command line flags. It's saying that there's no such command submit. That's not great.
That's interesting.
Is it just run?
Let me see what I did. No, it worked for me.
Works on my
I'm
machine.
trying to see. Yeah. What? I'm trying to see. Did we skip a step? Wait.
Oh, I didn't set the
was
pipeline
Endpoint
ID.
set up?
I didn't set the pipeline ID.
Yeah. I was just thinking that. Like, did we set all the variables?
So that meant this was blank, but then the error is no such command submit. That's a head scratcher.
It is a head scratcher.
All right, let's set this pipeline ID and see if that fixes it, because it sounds like it's a real error message error. Cool. So it's going. So maybe we can I'll someday look into that and maybe submit a pull request to Kubeflow Pipelines.
I love that statement that it works on my machine. But the funny part of that statement is like we literally have the same environment.
Yep. By definition,
like we're running on the same
container
platform, the same container. But yeah, that's
true.
a funny statement.
Yeah.
That happens all the time. Yeah.
So here's our run. It's showing up in the UI. It is upset with me.
Figured out.
Yeah. It does look like this is the one we just ran. Let's see what it says on the Jupyter Notebook side.
Yeah, BigQuery query.
So it doesn't say anything about the error. It just says it's kicked it off. Monitoring the run. Okay, so you monitor it in the UI.
Yeah, you monitor it in the UI. Yeah.
So our BigQuery. Oh, 2 of them succeeded. Interesting. Where would we see? We got logs here. That's a starting point, right? What are we seeing? Let's see.
I can't see that very well.
Yeah. Let me make the window. See, callable fire. So I'm going to try to get to the bottom here. Okay, here we go. Already exists dataset CloudML demo splits. It must be trying
you already ran it. Yeah.
Well, I didn't already run it though. That's the thing. And what was this one doing? This is BigQuery, the first one. Because like this should be rerunnable, right? That's the whole point.
Yeah, that's interesting.
So it's saying it's trying to create a data set of a certain name. KFP component, create this data set. And the data set is called splits. So I didn't create that before.
Check BigQuery.
Yeah.
I always when I go through these, I'll have like multiple tabs.
So many
I'll have, like
tabs.
the jobs, the logging, platform notebooks, pipeline, BigQuery, the bucket, cloud build.
Yep.
and then probably another, another Jupyter Lab tab, something else,
Yeah,
and then Stack Overflow whenever it debugs.
right. I'm just so glad that I don't have to run all this stuff locally, that we have
Yeah,
all this stuff.
it's
Because,
great.
like,
Yeah.
especially here, I'm trying to live stream at the same time. So having that kind of CPU load would not be a fun time. So here's
Yeah.
our splits data set. So, like, these output tables are here. I
Mhm.
definitely created this on its own, so to speak.
Yeah. But I think there's probably there's a bug
Uh-huh.
in the code, I think,
Yeah.
that prevents you from rerunning it if there's already a data set that exists. So you probably just need to
Delete the data set.
add either that or just, have some conditional logic that says if it exists, don't try to create it.
It looks like this was called from, so you see here, it talks about launching it, and then it talks about fire.
Yep.
And so I'm guessing they ran some fire here. Component, well, that's in fire/core. I'm curious what the top level run was, right? It was like main, exec code.
Run Python up.
The reality is we need to find the source for this component, and who called it, because this is a built-in component, and we have inputs like this. It's funny, input ID, input parameters has dataset ID called splits. But yeah, we could try just deleting the dataset if you want. But
Yeah.
did it
let's do
work
that.
for you?
Yeah, it did. But I haven't tried running it multiple times.
I know, but what's funny is I haven't run this multiple times. Like that just now was the first time I've ever run it.
I don't believe you. No, I'm just kidding.
All right, so let's delete this data set. And I definitely didn't have a data set called splits beforehand. So, all right, so that's gone. Wiped away, wiped clean. And we're going to see pipeline ID should stay the same. Run ID should get updated to 2. Source table, data sets, evaluation threshold, classifier version, replace. Everything else looks the same. So I'm going to run that cell, and we'll run this.
Oh, you know what? You remember when you ran it and the submit errored out? I bet you it created the data set.
Ooh, interesting. So even though
Kubeflow
Pipelines,
it partially completed, but I don't know. It doesn't even sound possible. But
all right.
yeah, let's go back
Next
to
error.
run 02.
Now the other 2 failed. We created the data set successfully, but the queries failed.
No, one failed again. So.
Oh, right. The ordering was wrong. Well, that explains why. Now, how did 2 succeed?
Yeah, it's curious.
Doesn't 2 reference the table splits? So 1 is going to be the same sort of error, I assume. Create data set.
Look at the bottom.
Already exists. Data set CloudML demo splits.
That's odd.
And then the other error. Watch it complain that the data set doesn't exist. Already exists. So it's only one of them can execute.
No, this is weird. This is a strange bug. And yeah, I didn't face it actually. So I'll have to try it again and see what happens.
Is there a way?
Yeah, let me I'm gonna run it in parallel just to see if I run to the same thing.
Okay, maybe it's not a timing issue, but there's a issue right now, and BigQuery is taking its sweet time to refresh. I want to take a look at how we're calling BigQuery, right? Because we've effectively reached the end of this lab. We've kicked off a run successfully. We've kicked it off successfully. We haven't completed it successfully. And so I think what we can do is try to dig into where we're making those BigQuery calls in the source code. And so this pipeline, cover type training.py, which we have open here, and we have a couple of different calls to BigQuery, right? We have this BigQuery query op, and we use it 3 times. Well, if I can press enter.
So my queries all ran successfully.
No way.
Yeah, it's weird.
Maybe I did something
Um,
wrong in the setup process of.
yeah, I'm wondering if maybe there's a variable that's like incorrect. And just for the sake of the audience, I will paste a screenshot.
Okay.
Where can I put it?
Oh, wow. Yeah, where can you put an image that I can display? Hmm. This is a new
Yeah, I'm
problem
gonna.
that we haven't encountered
I
before.
know. Can't email you, can't chat you. We'll figure something out.
Hmm.
I can print an image of it and just put it right on front of my camera
Yeah.
as
Do
a
you have
physical
do you have
document.
a Polaroid or something?
Yeah. If I had a mirror, that would work.
Yeah. Tibor suggests putting it in a storage bucket and making it public, and you can drop the link into the chat.
Oh, I could do that. Yeah, I'll do that. It's a good idea. Why didn't I think of that? Yeah, I'll put it into a public bucket.
So here's our lab. Okay, so BigQuery. Op is this BigQuery load component. And then, so I'm gonna in parallel kind of poke around to see if I can't figure out. Okay, so this BigQuery query op,
Yeah.
it has a training file path, dataset
Yeah,
location.
check all of those because I'm wondering if maybe it's one of those variables hasn't been set properly.
Hmm. I mean, I noticed that table ID is hard coded, so I assume that's intentional.
Wait a minute. Is it? Let me look at mine. Cover. Oh, you know what? No. Let's see.
We do something
Looking
silly.
at my code right now. I wonder if we accidentally deleted it or if we didn't set it properly. Let's see. No, it is. You're right. It's blank.
And the text above it doesn't talk about needing to make any changes with regard to that particular piece of things.
Yeah.
Well, what I'm trying to do is
see.
understand this BigQuery op, right? Because it comes to us from. Wait, what's that? Uh-oh.
Where you set up like your.
All right, I think we're back. Sorry about that,
Yep.
folks. Things went a little haywire for a second. Brian, can you reset your camera? There we go. Okay.
Yeah, sure.
No, it's on again. Sorry, it took a little second.
Okay, so what I was saying is if you come out of this file and you go into the lab2 notebook,
Yeah.
I think there's a step where you set the region endpoint, the artifact store, and the project. I just wanted to check something.
Which, do you have a line number on it, maybe?
It's the 5th step. I don't know. If
Oh, yeah, there's no line numbers in the Jupyter Notebook. That's true.
yeah,
So is it after this big thing? Oh, here, region,
Yeah.
artifact store, endpoint, this bit.
Yeah, I just want to check, is that region correct for you?
For what is this region should be? The compute region for AI platform training and prediction.
Yeah, well, I guess that's different, but
I mean, this is where the pipelines is hosted, US Central 1A.
yeah, central. Okay, you're good then.
So that should
All right,
be
because I said it.
fine.
I put mine in east.
Uh-huh. Because then it wouldn't have connected at all. We wouldn't have been able to push
It's true.
anything into it.
Yeah.
What's interesting here is that this cell runs project ID and then selects the first value of project ID and saves it back in. What's up with that?
I don't know.
Like,
It's the first
what
time I've
is
seen
what is
that.
project ID value? Okay, it's CloudML demo.
It's printed. Yeah. Glad I'm a demo. Okay.
As long as we don't run this cell twice, we won't change our product ID to just the letter C. All right, so let's see. It does say open settings in your host instance from the value of host from a Kubeflow client via. No, we already have that. Because I think it would be potentially useful for folks to see the oh, I see. The thing is, the component is just the YAML file, which is going to be this fun. Oh, it actually doesn't look terrible. I wonder. So the three queries we're running, right? They're all based off of the same templated query. This generate, where is it? Generate query, sampling query. And it draws from this source table, and it says all these things. And it talks about how, like, there's nothing in this query about the data set. And then we take that, we have this BigQuery op, right? We just wrap this helper function in this, BigQuery op, and then this function gets called to set up that op. So then when we're using the op, we call generate sampling query to generate the query variable. And that's what gets passed as this input to the op. And what gets passed here is a project ID and dataset ID, as if they, might exist. And so now I want to see in the dataset ID. Okay, so this is an example. I'm going to go back for a second and look at the documentation for this component.
So here's a thought. You know how you created the image? You like pre-built the image.
Yeah.
Earlier. I wonder if you built the image with the wrong settings, like the wrong artifact URI or something.
Oh.
In the wrong region. It's just a possibility, because I can't think of anything else that would throw off this pipeline.
Well, these variables were set to the same values they already were before. Like, I don't think we changed. I'm trying to think. Yeah, you're right. Did we change anything?
We might have changed the ID, but I can't remember. No, that wouldn't have worked. Maybe the artifact store?
Yeah, that wouldn't have worked either, though.
I don't know.
Like, you're talking about this endpoint? Or, the GCS path?
Yeah, but I don't know. I think you changed it before you built.
The ID of the persistent dataset. If the dataset does not exist, the operation will create a new one.
Yeah, I'd be curious to see if anyone else runs into this, because I have not had this problem.
What's really weird to me is that I don't think this is something that we necessarily did. Like, it might be a bug in the way this is done, because it's somehow not realizing that the data set exists, but then, it's a race condition. That would be my guess.
Okay.
I think what's happening is they're detecting whether or not the data set exists, concluding that it doesn't, and deciding to make one. And so you have three of them all deciding at the same moment, yeah, let's make a data set. One of them wins, and the other two are like, what happened? So I think I should try rerunning it without deleting the data set, because then nobody is going to try to make the data set again.
And you know what I'm going to guess? I'm going to guess something's going to pass.
What do you mean?
I'm going to guess that something's going to pass. We'll just see. I put my bets on that for some reason.
What do you mean pass, though?
Well, like, I think it's going to work. Yeah. One step is going to work, and a few.
Something else will break, though.
Yeah, we'll see.
All right, so that's submitted. Let's go back to our experiments, and we can expand that experiment. If you don't want to do that, you can always hit all runs over here and kind of get a flat list of all your runs. So I'm going to click into this run, and we're waiting. It's an exciting moment. Oh my goodness.
Oh, wow. It's going.
So it turns out all you have to do is just kick the machine and hit reset and say, do it again. Run again. Oh, man.
It's a little bit too flaky for my liking.
Right?
So, yeah.
So perhaps this indicates to us that the way this is structured, and we can see it here, these three queries don't depend on each other. And so pipelines is just like, just run them all. Run them all. They're the first thing in their respective dependency graph. So we might want to have some kind of check first before we run any of the three as like a separate step.
Like the data set step. I mean, it's interesting that the operator requires that the data set be created. either that, or you create like some sort of linear condition so that like the pipeline query 1, 2, 3 are run separately in order,
Yeah.
so that
So that's actually a
as
good
an
question. How is it that we're chaining, like, for instance, this one into the one before it? Is it just because
Yeah,
we're
that's the code. It's the KFP code that
Mhm.
you or the Python file that you had.
Right?
You basically like set up the dependencies.
So
And I'm
can we
trying to
see
see
if we
where
can
it
find
happens.
where that's actually happening? I think that'd be
Hmm.
interesting for folks. So this is the code in GitHub, just because it'll be bigger and easier to read. Um,
Yep.
so here we have the various components loaded in, and we have this cover type train. And so, for instance,
Yep.
here's one of our BigQuery ops, create training split, and we use that down here. We set these tune args, and again down here for train args, and that's it. So now I guess I could see what train args, where train args are used. That's here when we call the ML engine training up. We're passing in these arguments, one of which is this training split.outputs. So we're tying the outputs of one thing as inputs of the next thing.
Yeah.
Okay. So that's kind of how it's implicitly being wired together.
Yeah, and it's a little different from like Airflow is kind of nice if it's a similar thing, but in Airflow, you just at the end you tell it like this is what you do. These are the steps, and you branch it this way, and so you kind of have all the code in one place, which makes it easier to manage. Here, it's a little bit, you know, you have to dig into the code, right?
Yeah.
And you have to kind of trace back, kind of similar to what you would do in any Python code. So.
Right. And like just, it took the two of us this hour to get it set up and like kind of figure out what's happening there and change all the things. And we, of course, we didn't write most of this from scratch. Most of it existed. We were more than happy to read through it and talk about it. But there's a lot there. And even, we didn't even look too much at like what these tables were being generated. But I think they're just samples of the existing data set, not too much going on there, because we saw in the query, right, it's just that this select statement with kind of a sampling.
Yeah, if you want to show, actually it's a little harder to read here, but if you want to go back to lab 1,
yeah,
and just to show the viewers, basically this is just taking the query that does the the training and validation split from lab 1, and then basically writing it in a way that can be in that template for the Kubeflow pipeline.
Where is that? I have the lab 1 open.
Lab 1.
I actually don't see it. Oh, here we go. This is the query. It runs it as a command line BigQuery query.
Yeah, exactly. So that's basically what they took, and then if you see, it's hard-coded numbers here, right?
They templatized it.
They templatized it so that the parameters are passed in for those.
Gotcha. So they ran these manually, basically, and threw them into CSV files.
Yeah, and that's what I was mentioning. It's nice to go through lab 1 because then you're like, oh, okay, I get it. I get how this works. And then you go to 2, and then like, oh, I see how it's different when you try to get it into a pipeline. And then 3, which we're not getting to right now, it's like, how do I make the pipeline run when I have a change on my GitHub repository?
Yes.
Which is pretty cool.
So let's see, 3 is about making CI/CD setups with Kubeflow pipelines. That's amazing. Right. So yeah, definitely add this to kind of the list of workshops and tutorials to kind of run through. This looks really cool. I think, definitely do that at a later point in time. But for now, our hour is at an end. I want to thank everybody for joining us. Thank you so much for saying hello, and thank you, Brian, for being on the air with me today and kind of helping walk me through this and really understand a little more about how Kubeflow Pipelines fits together. And
thanks for having me. Yeah, and appreciate everyone who joined to listen in as well.
All right, thank you so much. Wish everybody a good weekend. Same to you, Brian. Be well, be safe, and we'll catch you next week. On Monday, we'll be doing a TFX version of this. We'll run it on Kubeflow, but we'll be using TFX code and seeing how that's different. Tibor wants to know, one last question. After successful deployment, can you set up monitoring for your pipeline? So is that just like, can you elaborate what you mean by monitoring? Is that mostly around making sure it's running and logging and things like that? Or are we talking more about kind of what Lab 3 might be talking about?
I think I can respond to that. Okay. It's all of the logs that are generated by your pipeline are going into, the stack driver, is it stack driver?
Yeah.
Whatever. The logging Google and monitoring. Yeah, behind the scenes. And so you can monitor that and, set up watches and reporting and all that stuff, similar you could do on whatever service you're using.
Awesome. All right. Well, thanks everybody for joining us again. And we'll see you next week on Monday for TFX. And Wednesday, we have a very special data show with Felipe Hoffa.
Awesome.
We have some exciting stuff planned. We have a bunch of guests coming and some secret unveils that I won't give away just yet. So don't miss out. 3 p.m. Eastern, noon Pacific. We'll see you next time.
Have a great weekend, everyone.